All right, welcome to our video on the metric system. So this is still continuing our little series on how to do sciencey stuff. Last time we were looking at scientific notation. This time we're going to be taking a look at the metric system. So systems of measurements have been around for a long time, actually. Ultimately, a system of units is going to give meaning to whatever the numbers are. So in science, we don't just say that something is 10, we're going to attribute some sort of unit to that, and that unit's going to have meaning. Are we talking about forces? Are we talking about lengths? What are we talking about when we say a number? In science, we really want to know what that number is. A long time ago, a lot of these units were defined very imprecisely. One of my favorites is the furlong. The furlong was the distance a team of oxen would plow a field before needing a rest. That's a really imprecise and inaccurate sort of measurement when you think about it. It depends upon what sort of oxen you have and what's going on with the fields, how good is your plow, all these sorts of things. They've changed that actually. The modern furlong is just an eighth of a mile. But we want something a little more precise than that. And the metric system gives us very precise definitions. This is an image of the definition of a kilogram. It's kept under intense vacuum at very special buildings. The international standards are all kept in very special places under very controlled conditions. The metric system uses these and also it uses a decimal system. So everything's going to go up by a factor of 10, kind of makes it very useful for the scientific notation piece, and just is very simple numbers. So unlike the American system where you have 12 inches to a foot and 3 feet to a yard, 5,280 feet to a mile, everything's going to go up by factors of 10. It's actually very widely adopted. We're one of the few countries that doesn't actually use the metric system. The cool thing about it is that, unlike my example with the imperial system, where you have inches and feet and yards and miles, the base word for a unit stays constant. So, for instance, length is always the meter, volume is a liter, mass is going to be a gram. And this year, we're going to be working with a couple ones that might be new to you. We're going to have forces a lot once we hit January. Forces are going to use newtons, and energy is something that we're going to be talking about constantly this year. But energy uses a joule. Now, if I want to get big or small, I actually use a prefix. So I don't change my base unit. I leave that the same. So I just add some sort of a prefix like centi could be added onto meter to create a centimeter. And centimeters are much more small than a meter would be. While I could add a kilo to a liter and have a kiloliter, which would be a lot of volume. One thing you want to start doing with this is trying to think about how things fit, get some sense to these numbers. So ultimately, let's start by looking at the base units. Let's say you had a tree branch. Well, a tree branch might be about 1.5 meters long, while a room, well, that might be about 5 meters across. And if I took a ball of twine and I let it all go, let it stretch out all the way, I might have about 25 meters of twine. That's great, Those are all going to use meter very well. But what if I wanted something really large? What if I wanted to go to the mall? If I was trying to get from my house to the mall, let's say I got about 10 miles to go. Okay, no worries. Well, 10 miles, that would actually be 16,093 meters. We'll talk about how to convert units in our next video. But for right now, just go ahead and roll with this. This is 16,093 meters. I got to go. Well, that's pretty big. So instead of just using 16,093, I'm going to change my units around by adding one of those prefixes. So in this case, I'm going to change meters to kilometers. 16,093 meters would be 16.093 kilometers. And I could round to 16.1 because that 0.093 is pretty weird to use. So I'd say it's 16.1 kilometers between my house and the mall. So the common prefixes that we're going to use in this class really are listed here. Ultimately, milli, centi, and kilo are the most common. I don't use most of these other ones very frequently. You may have heard of some of the other really large ones. For instance, I have a terabyte hard drive. So gigabytes are where we're currently measuring RAM. Now I'm dating my video, so we'll come back in 20 years and see if that's still the case. So let's say I want to do some conversions here. I want to move 7.3 kilograms over to milligrams. Okay, kilograms to milligrams. So the first thing I would do is I would write down the units I was given. I'm given 7.3 kg, kilogram. And now I'm going to go to a conversion table here. And I'm going to look, and I've got kilograms, well, that's 10 to the 3. And milligrams is 10 to the negative 3. And what I'm actually going to do is I'm going to subtract those numbers. So 3 minus a negative 3 is a positive 6. Okay, so there's a factor of 6, 10 to the 6, between these two numbers. And that's going to be my conversion factor. So I'm going to set this up. So I'm going to multiply it by a fraction. And the fraction is going to get lined up so that the kilograms are going to cancel out. So kilograms are going to multiply by kilograms. They're going to go away. And I'm going to be left with milligrams. In this case, I'm going to have 7.3 times 10 to the 6 milligrams. There's a couple of things here, and this is going to be expanded upon next week in our next video. And the big thing goes into the next video is these conversion factors. 10 to the 6 milligrams over 1 kilogram is a 1. It's a giant 1. It doesn't look like it, but by definition, 10 to the 6 milligrams is 1 kilogram. Now, I have lined up this 1 in such a way that the kilograms on my 7.3 cancel out with the kilograms on the 1. So that all that's left units-wise is milligrams. That's really important when we move to talking about unit conversions between the imperial system with feet and miles and all that stuff and the metric system, because you want to line up your units in such a way where they cancel out. The other thing that's really cool here is there's no actual multiplication or anything going on as far as like things you need to calculate. It basically writes itself in scientific notation. 7.3 times 10 to the 6, because dividing by the 1 doesn't actually do anything. So as far as a mathematical process, even though these numbers are being multiplied together, there's no actual work for you to do using this kind of method. Let's look at another example here. I'm going to convert 2.5 milligrams up to grams. So again, I start with 2.5 milligrams, start with what you're given. It's going to stay the same even next time when we're looking at converting between systems. So here I have 2.5 milligrams, and I'm going to find in the table that 10 to the negative 3 is for milligrams. And I'm going to actually use a 0 this time because grams is the base unit. So negative 3 minus 0 is still negative 3. I'm going to do the same thing as I did last time. I'm going to multiply by a conversion factor, a giant 1 that relates milligrams to grams. And that conversion factor says that there's 10 to the negative 3 grams in every 1 milligram. Milligrams going to cancel with milligrams once again, and I'm going to be left with just grams. In this case, 2.5 times 10 to the negative 3 grams. Now this example is pretty small, and I did that on purpose because there's another way to handle this. And since you always want to do whatever's easiest, you could just move the decimal 3 spaces. So you could start with the 2.5 milligrams, and you could move 3 spaces to the left in this case, and get 0.0025 milligrams. It's sometimes not feasible to do this. If we were dealing with the number of atoms in a drop of water, for instance, there's so many there, it's like times 10 to the 21. And you don't want to necessarily move a decimal place 21 times. It's not feasible. And when you look at a number that's got 21 zeros on it, it's hard to make sense of it. So when you're dealing with something like centa or milli or kilo, it can sometimes be easier to just move a decimal place. The method of using unit conversion and dimensional analysis is the big fancy term. That method of lining up the units so that they cancel out and you're left with what you want works for any size. So you could take something that was incredibly small and convert it to something that was incredibly large without much problems.